A group of frogs called an army is living in a tree. A frog turns green when in the shade and turns yellow when in the sun. Initially, the ratio of green to yellow frogs is 3-1. Then 3 green frogs moved to the sunny side and 5 yellow frogs moved to the shady side. Now the ratio is 4-1. What is the difference between the number of frogs and the number of yellow frogs now? Green frogs and yellow frogs. Okay, so initially the G to yellow, green to yellow, was 3-1. Correct? So that basically means that 3y is equal to G. And then what happens is 3 switch sides, I guess, and then 5 switch sides. So 3 move away, so they're going to turn yellow, and then 5 come into that shade, so 5 turn green. And then very similarly for the yellows, it would be the exact opposite. It would gain 3 and then subtract 5. Basically an interpretation of that sentence right there, that 3 green frogs move to the sunny side and 5 yellow frogs move to the shady side. Now they're saying this is 4-1. Okay, not a problem. So that's going to be G plus 2 is y minus 2 is 4-1. And if you cross multiply, it'll be G plus 2 is 4y minus 8. And then we will insert that fact. And when we do, we get 3y plus 2 is 4y minus 8. So therefore y is 10. If y is 10, then that means that G would be 3y, which is 30. And therefore, what are they asking for? The difference between the number of green frogs and the number of yellow frogs. So G minus y is what they're looking for. So that'd be 30 minus 10, and that's 20. Hold on. So I messed up here. That's initially. Oh, they want now. Oh boy, that's a key there. The word now. Okay, now it's G. This here now is G plus 2, which would be 32, and now it's y minus 2, which should be 10 minus 8, which is 8. So 32 minus 8, which is 24. Oh, the importance of reading the question carefully, and that would mean the answer is E. A roll of tape is 4 inches in diameter and is wrapped around a ring that is 2 inches in diameter. A cross-section of the tape is shown in the figure below. The tape is 0.015 inches thick. If the tape is completely unrolled, approximately how long would it be? Round your answer to the nearest 100 inches. Well, the entire thing is 4, so from here to here, that's going to be 4 minus 2, and then divide by 2 because it's on both sides. So that's going to be 1. So that's 1, that thickness, I guess, of the roll. Now, they're saying the tape is very thin, but it does have some thickness, 0.15 to be exact, and that's approximately 66. So, then what? Yeah, this is the average. This would be the average. This is actually representing the number of times that would go around on average. So 66 circumferences. Yeah. And then what we'd have to do is sort of figure out what is the circumference. Yeah, because you're going around 66 times, so then you have to figure out what is the average circumference length. Well, circumference is equal to pi times diameter, right? And the diameter, well, then we'd have to look at the average diameter then. So if you're going, the middle one, the middle circumference would represent sort of the average diameter. And that middle circumference, if you calculate it, would be from there to there would be 2 plus 1, so 3. So it'd be pi times 3. Yeah. Okay, so the average circumference is 3 pi, and we have 66 circumferences, so you multiply it by that, and that's going to be, well, let's do this, 3 times 3.14 times 66, and that's approximately, well, that's 200 times 3, 600 approximately. And this is by far the only one that's even close to that, so the answer would be B. Rodrigo has a very large sheet of paper. First, he draws a line segment connecting point 04 to 20, and the colors of the 4 cells whose interior intersect the segment are shown below. Next, Rodrigo draws a line segment connecting point 2000, 3000 to the point 5000, 8000. How many cells will he color at this time? Okay, so this is a classic extrapolation question. Extrapolation, meaning first we'll figure out how many points between those two, and then we'll multiply it by a certain factor, and we'll figure out what that factor is. But first, let's carefully see what we can do here. So we're going from 04 to 20. Okay. Oh, that one they already gave, and then we're going to from there to there. Okay. So obviously I'm not going to draw that many, so I'm just going to do 2, 3 to 5, 8. And then whatever I get, I'll multiply by 1,000. That's what I mean by extrapolation. Okay, so let's do this carefully. 2, 3 is, well, actually, I need another grid here. But they've got such a nice grid. 2, 3 to 5, 8. Let me just use this grid here. And I'll put 2, 3 here. This point. I know that's the origin, but I just wanted to use that. 2, 3. So pretend that's 2, 3. And then 5, 8 would be another 3 going this way, and then another 5 going this way. So 1, 2, 3, 4, 5. Okay, so there to there. And then let me just join that and see what I get. Okay. Okay, so now let's carefully count how many squares it actually intersects. How many cells? Okay, so this one, the red line, 2, 3, 4, 5, 6, and 7. I hope you can see that. It's a bit subtle, but there's 7. So there's 7 cells that intersect or cross when you go from there to there. So you have to multiply by 1,000 to sort of figure out that one. So it'd be 7 times 1,000, which is 7,000. So I think that's pretty much all that is. And therefore, number 23 would be C. Jean has made a piece of stained glass art in the shape of 2 mountains, as shown in the figure below. One mountain peak is 8 feet high, while the other peak is 12 feet high. Each peak forms a 90-degree angle, while the straight sides form a 45-degree angle with the ground. The artwork has an area of 183 square feet. The sides of the mountain meet at an intersection point near the center of the artwork. H feet above the ground. What is the value of H? Okay, so there's many ways of doing this question. I'm just trying to think what's the best way here. I think, let me just draw some lines carefully. That one, and I think I'll do the same thing coming from the other guy. I think that one. I think that probably is the best approach, so let's see what happens. Now, the smaller triangle, that's a right angle, as you can clearly see. And, I think I have to draw a couple more lines here. Top to bottom, I think those will help. So like a perpendicular line going top to bottom there, and then another perpendicular line going top to bottom here. Yeah, that should be sufficient. Okay, now here we go. So let's label this now. They gave me that 8. So that means that red line is also 8 because it's exactly parallel and it's perpendicular. And then therefore, since that's 45, this angle will be 45, and this is a right angle. So that means the distance from here to here, that's also 8. And then this hypotenuse I'll call y. So therefore y squared is equal to 8 squared plus 8 squared using Pythagoras. And therefore y would be 64 times 2, and take the square root, so 8 root 2. In a very similar way, this guy is this is going to be 45, therefore that's going to be isosceles, and therefore that's 12 and that's 12, and then we'll call this guy x. And in a very similar way, x squared is equal to 12 squared plus 12 squared, and therefore x would be 12 root 2. Okay, so that means what? What do we do here now? They've given us the area. The area of that whole thing is 183. Okay, so that's very helpful actually. So that means that if I take the area of the smaller triangle, which would be 1/2 base times height, which would be basically 1/2 times 1/2 times y squared, right? Yeah, it's the area. Oh wait, before I do that, I need to figure out the h in a very similar way. I'm gonna have to. This is 90. This angle. Let's see here. This is going to be 45, and this is also 45. So therefore, this is also h, and therefore, if this hypotenuse would basically be h root 2 in the same way that we've done over there. Okay, so now we can figure this out. So 183 would be 1/2 base times height, and the smaller triangle would be y squared, and then plus the big guy, which would be x squared, and then we have to subtract from it this one, the one in the middle, the one right there, because that one is double counted when you add the small triangle to the big triangle. So subtract from that 1/2 base times height, which would be h root 2 all squared. So this looks like to me, y squared is 64 times 2, so this is going to be just 64. X squared is 144 times 2, so that's going to just be 144, and that's just going to be 8 squared. So when you do this math, 8 squared is 25, and therefore h is 5, and therefore B is the answer to number 24. A small airplane has 4 rows of seats, and 3 seats in each row. Eight passengers have boarded the plane and are distributed randomly among the seats. A married couple is next to board. What is the probability there will be 2 adjacent seats in the same row for the couple? So, like any probability question, we have a fraction, and this is going to be the total on the denominator, and the numerator will be our specific condition. So let's talk about this. Specific condition or total? Which do you want to do first here? Let's see here. Well, I think the total should be easy. We've got 2 spots that we're really interested in as to where the couple boards. Yeah. Well, the total, since there's 12 of these seats, you could have 12 possibilities for the first and 11 for the second. So that's 132. That's the total. But of course, our specific condition is completely different because 8 people have already boarded. So that makes things different. Okay. So our specific condition states that we have 8 people who have already boarded, and we want the couple to board so that there's 2 adjacent seats. So for example, let me just make a little diagram. I'll just give an example. We want 2 adjacent seats. So for example, we would want these two to be empty so that the couple can sit there. So the 8 could be occupied like this: 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. And then the couple, we'll just call them C, can sit there. So that's one example of something that would work. So, how many ways are there to do that? What I just drew. This is just one possibility. Let's see here. You can have the two C's like this, or you can have the two C's here or here. That's another way. And then similarly, there and there could be the two C's, or there and there. And then similarly, there or there, or there or there, there or there, or there or there. So for in each row, there's two ways. So 2, 2, 2, 2. That'd be 8. So 8 ways of making two seats adjacent. Yeah. But here's the thing. When you do put those C's in, you now have 10 seats occupied. And those 10 seats can be arranged in a way, because you have 10 people. Since we have 10 total people on the plane, we should multiply our numerator by 10 to account for all the ways that those 10 people could be seated. So that would mean this would have to be multiplied by 10. So that makes it 80 over 132, and in lowest terms, that would be 20 over 33, and that is choice C.